Good morning, everyone, or good afternoon, good evening, wherever you are in the world. I know that there are some people joining us from far-flung places, so whatever time of the day it is, welcome. Thanks for joining us. My name's Alison Starkey, and I am the Communications and Marketing Officer at Sugar Research Australia. Today we've got Phil Patani from SRA and Brendan Nothard from DAF, or Department of Agriculture, from DAF, who will be presenting on the topic of adoption of practices to mitigate harvest losses. So the webinar will consist of a presentation for around 45 minutes, or sort of actually what we're going to do is we're going to break it up into two sections. So we're going to hear from Phil for around about 20 minutes, and then we'll have hopefully a 10-minute Q&A session for Phil, and then we'll swap over to Brendan, and he will present for another 20 minutes or so, maybe a little bit longer, and then we'll have another Q&A session after that. We're sort of hoping to wrap it up within the hour, but it may go slightly longer. So if you're unable to stay for that little bit of extra time, then obviously you can view the recording later on. During the presentation, if you can keep your microphones on mute, that's always really helpful. You can type in questions via the chat function. So if you're not sure, if you're not familiar with that, there's a little speech bubble icon, which is the second icon on the left on that top black bar. You can open that and you'll be able to see the chat window appear on the right. So Phil and Brendan may respond to your questions kind of as you type them, or may hold on to them until the end, depending on whatever's going to work best. So if at the end during the Q&A, again, you can type your questions into the chat, or you can raise your hand and kind of that notifies us that you have a question you'd like to ask. And if you're not familiar with that, there's a little hand icon, which is the third one from the left on the top little bar. And if you can go back on mute whenever you're finished speaking. Yeah. Okay, I think we've got everybody's text kind of getting sorted at the moment. Towards the end of the webinar too, I'm going to put a link in the chat, which will be to the link will be to a form. So just a survey. It takes probably around about 2 minutes to complete, and it's really helpful for us to get some feedback from you as to you know, the value that you've taken from the webinar, and then we're able to obviously you know, address kind of any concerns you might have or follow up. It's very useful for us to understand what's what is useful to our audience, what information. So now I'll just introduce both of our presenters at the same time, or at the beginning, and then we'll hear from both of them separately. So Phil is the Agricultural Machinery Specialist for SRA. He graduated with a Bachelor of Agricultural Science degree from the University of Queensland and has been specialising in minimising harvesting losses since 2013. He's led 3 harvesting projects, including project number 2014/048, increased harvest recovery, reducing sugar loss and stool damage, another one, adoption of practices to mitigate harvest losses, and then part 2 of that one. So Brendan holds a senior agricultural economist at the Department of Agriculture and Fisheries in Queensland. He holds a Master of Science in Agricultural Economics and has over 15 years of experience in sugarcane economics. For the past 4 years, he's been involved in economic modelling for SRA harvesting projects. Those ones include some of the ones that Phil's also been involved in. His involvement in the Australian sugar industry includes investigations into the economic impact of cane harvesting practices and new farming systems. So I'll now hand over to Phil to share his screen, and he can start his presentation. Thanks, Phil. Yeah, that's great. I can see your screen. I don't know if you can put it into presentation mode or if that's just still coming through. Yep, that looks good for me. So hopefully that's good for everybody.
Perfect. Thank you very much, Alison, and welcome all today, everyone that has attended. We really appreciate it. So Today, what I wanted to go through was the wrap-up of the Rural R&D for Profit project, but in particular the extension component of it, which was titled Adoption of Practices to Mitigate Harvest Losses. Now, this project went for 3 years, so from 2017 to 2019. And so the results will be presented today. However, the exciting part of this is that the back end of this presentation, Brendan Nothard from the Department of Agriculture and Fisheries will present the next step. So exciting times for the Australian sugar industry where Sugar Research Australia and the Department of Agriculture and Fisheries are producing a harvesting predictive tool. But I won't steal Brendan Nothard's limelight. I'll let him present on that and looking into the future. But let's start off with the wrap up of the Rural R&D for Profit project. So, what if a change in harvesting practice could deliver an increase of 5% throughput through our mills with no increase in cane land? Inject an additional 5% in sugarcane yield with no increase in cane land, and alternatively deliver an extra $68 million into the Australian sugarcane industry. Now, these are all results conducted as part of the adoption of practices to mitigate harvest losses. So I guess to start off with is everywhere around the world identifies that there is some loss associated with mechanical harvesting, and mechanical harvesting does equate to a yield loss. However, what that yield loss is ultimately dependent on a range of parameters such as operator for one, and then machine setup and machine design. Now, we're not saying that there's ever going to be zero loss. That's not what we're saying, but what we're looking at is how can we minimize those losses and remain economically viable. So the current issue in the Australian sugarcane industry is that there is a decline in harvesters. So obviously groups are getting larger and larger and less operators or less contractors in the industry. In doing so, we've identified that there's obviously high ground speed to cover that area, in turn leading to higher flow rate, and ultimately with the higher flow rate leading to a higher fan speed. Sorry, someone's just
I think it might be Rachel. I'm not sure, Rachel, if you're able to go on mute.
Okay, thank you. Sorry guys, I can't see when people put up their hand or anything because I am presenting. So if there is an urgent question here, please feel free to jump in, or otherwise I can try and answer them right at the end. Okay, so in turn, just leading on to what we said about the increase in ground speed and increase in fan speed, on average, out of all the trials that we've conducted, we saw that there was an increase of 1 kilometre per hour from the recommendation and leading to 100 RPM higher on the fan. So when we talk about harvesting loss and then alternatively change in harvesting practice which impacts yield, there's been a range of work conducted in the past from, in 1984 from Herney et al. Identifying cleaning losses anywhere between 5 and 8 tonnes per hectare. Ridge and Dick analysed a wide range of losses relative to harvesting practice, field conditions, varieties and time of harvest. And Agnew et al. Investigated the impact of pour rate and fan speed. Now, all this information that has been collected over the past 3 decades has identified that harvester cane loss is strongly correlated to extractor fan speed, and extraneous matter is influenced by harvester pour rate and field conditions. So what is different about this program than other programs in the past, and why has, I guess, change in practice, why haven't we seen a change in practice as such? Now, I know everyone hears the term harvesting best practice, and I'm a little bit skeptical too, because at times when people hear the term harvesting best practice, they go back to the old mindset of saying that there's a set ground speed and a set fan speed, which is completely incorrect. I guess the thing that we need to look at is what is going to deliver the best value for money out of that field, and that comes down to delivering obviously minimal cane loss, but also not costing the operator and remaining economically viable. So What was different about this is, yes, we identified whether cane loss is real or not in the Australian sugar industry with over 95 replicated trials. But then further on to that, did a detailed economic assessment to see whether picking up that extra 5 tonne or 6 tonne or 7 tonne of cane per hectare was actually viable and it wasn't going to cost more than it to recover. So when we were looking at that practice change, it was looking at a targeted flow rate through that machine. So all dependent on cleaning chamber size. So whether it was, a 4'3" cleaning chamber, or around about 80 tonne per hour, or whether it was 90 tonnes per hour for a 5-foot cleaning chamber. So all dependent on chamber size would dictate what that flow rate was, and then in turn relate it back to ground speed. But we're looking at that flow rate. We then matched that with a moderate fan speed. So what the research plan was to establish a grower and harvester opportunity through demonstration trials. So the process was we'd have a pre-harvest meeting with volunteer groups. Would update them and say, okay, what was actually going to be involved in the demonstration. Would conduct the demonstration trial, which I'll go into a bit further on what was conducted, and then would do a post-trial workshop presenting the economics and then also showing an economic assessment. These weren't small-scale trials either, guys. I just wanted to highlight. So we conducted 95 trials from 2017 and 18, and then another additional 20 in 2019. Each trial was 500 tonne on average. So they were large, fully randomised, fully replicated trial to get a decent spread over the Australian sugarcane industry to see, on average, what we were looking at. So how the trials were set up, well, there were two components. So there was mass balance trials, which is purely as simple as measuring meters travelled by tonnes of cane in the bin by row spacing, which gave us tonnes of cane per hectare. We'd also get mill data, so we'd measure CCS to allow us to access tonnes of sugar per hectare, pole, bricks, fibre, ash, and so on. So you would have a whole suite of information. We then would also use the in-field sucrose loss measurement system. So the mass balance would give us tonnes of cane and tonnes of sugar per hectare change with the different practices, whereas the sugar loss trailer or the in-field sucrose loss measurement system would show us what was left on the ground or in the field. There was 4 treatments that were tested with these two methods. So the 4 treatments included a control treatment. Now this is not a recommendation. I just want to make that clear. There was a lot of questions and stuff in the past saying that, here's SRA and DAF saying 3 Ks an hour, 500 RPM on the fan. That's not the case at all. The whole idea of a control practice was to understand what was the total biomass in that field prior to harvest. So what were we sitting at prior to harvest? Then would move on to a recommended. And like I said, this was all dependent on a range of parameters. So the recommendation was based on what the variety was, what the estimated yield was, what the machine type and setup was, what the targeted flow rate was, and what the field conditions was. Now, obviously, we always talk about flow rate through that machine because that's what the cleaning capacity is. Yes, it does get referred back to ground speed, but there is no such thing as a set ground speed because if you're targeting, say, for example, a 90 tonne per hour flow rate in a 100 tonne per hectare block, yes, that's 5 Ks an hour. But if you're looking at a 70 tonne per hectare crop and targeting a 90 tonne per hour flow rate, well, you're up near the 8 Ks, 9 Ks an hour. So it's all dependent on flow rate through that machine and then matching fan speed from there. The standard practice, so what the operator would usually do in the field if we weren't there, with the standard flow rate and fan speed. And then the final one was the aggressive practice. So it'd be around about 100 RPM higher on the fan, just to show the upper end of the scale. And so pretty much how it worked was, this is your field of cane. These were your 4 treatments. So the control, the recommended, the standard, and the aggressive. And then, like I said, the trials are fully randomized and fully replicated. So a minimum of 4 to 6 reps per treatment, 4 treatments. And so how the day would go was You would measure the meters you would travel with a particular treatment. When that haul out was completely full, he would go and offload to the siding, would measure the tons that was in that bin, and then would move on to the next treatment. And that would be fully randomized, fully replicated through the entire block until either all bins were full for the day, which got us to our 500 ton, or the paddock was completely harvested. What was the industry results? Now, like I said, 95 demonstration trials from 2017 to 2018, and an additional 20 in 2019. So total biomass, like I was saying about that control treatment, there was 116 tonnes per hectare in the paddock prior to harvest. To get that flow rate that we were targeting of that 80 to 90 tonnes per hour, we're looking at from a reduction of 5.6 kilometres per hour to 4.7. That reduced flow rate through the machine from 110 to 89, and which meant that we had to slow fan speed down from just around about 800 RPM to 700 RPM. Now, sugar loss reduced from 700 kilograms to 550 left on the ground, and elevator flow rate obviously reduced as well with the reduction in ground speed. This changed the harvested yield from standard practice of 94 tonnes per hectare to 99. Now, like I said, this is over 95 trials as presented in this. So when we're looking at specifics and machine types and paddocks, that's all dependent on that one machine. But like I said, this is an average of all those trials together. So a range of harvesters, a range of field conditions, every variety you can possibly think of. That's what's involved in this data set, just to show you an average of what we're showing. What it identified was, as you can see, just purely focusing on the recommended and the standard practice. The blue bars on the left-hand side where it says delivered to mill is looking at clean cane yield. So you can actually see a significant reduction in clean cane yield alone from 86.3 tonnes of clean cane yield delivered to the mill to 83.6 tonnes per hectare of clean cane yield. Including the EM was 99.2 compared to 94.4. And then if you are on the other end of the scale, so the aggressive end of the scale, you're looking at 89.6 tonnes of cane per hectare, or 80.4. Now, something to highlight, and I guess if it's only one thing that you take out of today, is to highlight that for if you have an increase in flow rate and an increase in fan speed, for every above 90 tonnes per hour, for every 1 tonne of trash you try and suck out thereafter by cranking up the fan, you suck out 2 to 7 tonne of cane in the process. The reason being is that cleaning chamber, once it's overloaded, it can't differentiate between cane and trash, and we end up sucking out total material. So there is a balance. There is a balance. It can do a really good job when we're operating within its parameters. But once we start pushing the other end of the spectrum, well, that's when we start overloading the cleaning chamber and we start losing a large proportion of clean cane as well. On the right-hand side, that's just showing the sugar loss trailer. And what I just referred to then where I was saying about total material extracted, this is what that highlights. So if you see the blue bars there, it's showing total material left on the ground is 17 tonnes per hectare. So that's everything. That's leaf, that's tops, that's juice, that's cane, that's everything. Compared to, say, the aggressive of 21.8. So in doing so, by sucking out that large proportion of total material, you've also sucked out a large proportion of tonnes of cane and tonnes of sugar per hectare. So you've gone from 550 kilograms per hectare to 700 kilograms per hectare to over a tonne per hectare of sugar, not cane, but sugar. So there is, like I said, a balancing act. We definitely don't want to be on the bottom end of the scale of that control treatment because A, that's not economically viable to do that at all. And B, the effects of significantly reducing CCS, you will significantly reduce tonnes of sugar per hectare, but then we don't want to be on the upper end of the scale either. So what the results showed was by decreasing fan speed and ground speed for the Australian sugar industry, showed an increase in cane yield by 5.2%, an increase in sugar by 5%. Once you took into account, so if you just looked at grower gross revenue, the grower picked up an extra $181 per hectare. If you look at net grower revenue, so you take into account the additional harvesting costs, and I'm not an economist, so I'll let Brendan Nothad delve deeper into the actual cost of harvesting. But when you actually take in the true cost of harvesting as well by recovering the additional tons of cane that's required, because there is a reduction in flow rate, it still left the grower an additional $116 per hectare. There was no statistical significance or change in extraneous matter, bin mass, or CCS. So what it showed is that that large change in practice significantly changed cane yield, which in turn showed a statistical significance in also affecting tons of sugar per hectare, but there was no difference in EM supplied to the mill or bin mass. With the reduction of flow rate, it did reduce harvesting flow rate by 14.1%, no question about that. Bin fill rate by 7.7%, and harvesting rate, by 18.8%. So they're things that we do need to combat, because we're not questioning that you'll still deliver those tons of cane. The problem is that you won't cover the area in a day. So for example, if you're delivering an extra 5 tonne of cane per hectare, you're delivering more tons of cane per hectare. Problem is that you're going to struggle trying to cover the area in a day, which is something we need to combat. Now, for the guys that are burnt cane online, we've done a couple of trials in burnt cane, and I just wanted to present that today. So the guys that are in burnt cane, they can see for themselves that yes, there is a benefit as well. When we're talking about a recommendation, there is a recommendation in burnt cane. So yes, you're correct. In burnt cane, unless you've got a very poor burn, a large amount of that EM is already gone. So what we noticed with the trial is we don't need to change flow rate. There is no limitation in regards to that extractor unless it's a poor burn. And then you've got to go back to just like you're cutting in a green cane situation. But when it's a decent burn, and when I say decent burn, as in majority of the leaf is gone and there's just a bit of top left, there is no restrictions in regard to flow rate. So no change in ground speed. As you can see, there's a large, 145 tons per hour going through that machine, but it's clean cane. So what we assessed was, okay, if we're in a good burn, do we need to run the primary at all? Do we need to run the primary fan at all? I understand that if you reduce fan speed, there's a lot of guys saying that mud build up in the hood. Obviously because of the increase in juice, and also soil increases mud buildup. So if we have a good burn, does it impact EM? And is there any increase in cane yield? So we've gone from 859 RPM to the 0 RPM. Because obviously the change in fan speed, there was a change in elevator pour rate. So from no fan of 141 tons per hour to the aggressive of 137. So what it did show was the no fan treatment delivered 128 tons per hectare compared to the aggressive treatment of 123. Now there's only 14 trials in this data set. I just want to make clear. So there's still more work we need to do in burnt cane, but the preliminary results are showing this. What is really exciting to show, and I guess it is basic also to highlight, but because of that reduction in fan speed, so we've gone from the no fan treatment, 120.9 tons of clean cane to the aggressive 118.4, 128.4 total material versus 123.3. It also shows that not running that fan so high also delivered a reduction in fuel burn by 9.8 litres per hour. So what the burnt cane preliminary results showed is under a good quality burn, and I want to make that clear, good quality burn. If you've got a poor burn, you cannot do that because you'll absolutely get destroyed in CCS and recovered sugar. But under a good burn condition, not running the fan at all, showed an increase in cane yield by 4.1%, an increase in sugar yield by 2.3%. There was an increase in economic grower revenue of $206 per hectare, so 3.4%. And there was no statistical significance in change in EM or CCS. And harvester fuel burn reduced by 19.1%. So, in conclusion, adopting green cane recommendations increased yield for the Australian sugar industry, if it's extrapolated over the entire Australian sugar industry, can increase by 1.2 million tonne of cane. That's 164,000 tonne of sugar and a potential of $69.3 million available for the Australian sugar industry and supporting communities. There is no change in EM levels and thus no change in bin mass. And this highlights the need for a supportive tool to improve sustainability. The next thing is preliminary results for burnt cane. So preliminary results showed an increase of 5.1 tonne of cane per hectare and 480 kilograms of sugar per hectare. Reduction in fuel burn, no change in EM levels, and this just highlights the need, obviously, for further demonstrations in burnt cane. So I guess a question that I've been asked for the last 9 years that I've been working with Sugar Research Australia is, okay, where to from here? So we'll give a recommendation in the field, but then we turn around, drive away, and we're like, well, hang on a second. Harvesting encompasses, it's so complex, harvesting sugarcane. And why I say that is that it's the only crop where we're taking total biomass and delivering it to the mill. So what we're delving further into now and looking further into and developing is to allow industry with all this data, that it's your data, make it available to you. And how we're going to do that is develop a harvesting predictive tool. Again, Brendan's going to delve deeper into this, but just a basic highlight of the tool is pretty much a recommendation side plus a cost side. So is it economically viable to do this? Does my contractor really need a change? Or is currently my contractor doing the best possible job and there's no change whatsoever needed? Or if there is a change, how much do I recover? How much extra do I need to pay him? To support that though, there's a number of cane loss monitors out in industry. So obviously the recommendation of looking into yield monitors and cane loss monitors are critical. Live feedback in the harvester is key for industry. So you're able to see and make changes on the run. And then finally, with the harvesting predictive tool that Sugar Research Australia and the Department of Agriculture and Fisheries are really excited that we're producing at the moment, and it is in a project. And fingers crossed, by the start of this season, we'll have a prototype that we'll be testing. By the start of next season, fingers crossed, we're hoping that it's going to be out there available for industry and to try and get benefit from it. And so finally, leading to a cultural change. So the idea of the harvesting predictive tool is to have information, because information is key. If you're able to assess and see that there is a change needed and you need to pay your contractor more and you get delivered additional, $1 a tonne or 50 cents a tonne or 80 cents a tonne, this will allow industry to remain viable. And if there's 5 tonne of cane per hectare left in the field, why leave it in the field? Let's deliver it for industry. So just to wrap up, this project is supported by Sugar Research Australia through the funding from the Australian Government Department of Agriculture and Water Resources as a part of the Rural R&D for profit. I'd also like to significantly thank these people here, so the Department of Agriculture and Fisheries, Queensland, in particular their economists, so Brendan Nothard, Matthew Thompson, Mark Poggio, regional cane growers and productivity boards, milling sectors with all their support throughout the 2017, 18 and 19 season, and SRA operators. Thank you very much for your time.
Thanks very much, Phil. I don't know if you can see them, but there are 2 questions already in the chat.
Yep.
So are you happy to go ahead and answer those?
Yes, definitely. I've just got to find the chat here. Sorry.
Do you want me, I can read it out for you if you
Yeah,
like.
if you don't mind. Yes, please.
Yep. So the first one
Oh,
is from Peter, and
yep.
Peter has said, what is a good quality burn? Do we have
Yep.
some parameters or photos we can use as a guide?
Yes. Good. Yeah, really good question, Peter. We do now. So finally, we've got photos that I will be presenting in the Burdekin and in New South Wales of what is a good quality burn and what is a poor burn. In the 2020 season, BPS conducted with SRA conducted 4 trials in the Burdekin region, and with those trials, what it allowed us to highlight is what happens in a poor burn and what happens in a good burn. So we've now got photos, and I don't know what the best way to do this, Alison. Maybe I'll send them to you, and if you upload this, we can upload the photos as well with the presentation. We can identify what's a good burn and what's a poor burn, but simplistically, what it is that a good burn is that the stalk itself is a clean stalk of cane. There's not much leaf there, and that you're only left with the top with tops. A poor burn's classified that there's a large proportion of cane. The next question
Next, yeah. Mm-hmm.
Is there a difference with harvester speed between track machine and wheel machine? Look, that is a good question. In the trials, we didn't really look at separating the two together. So because our trials started from Tablelands and ended in New South Wales, in Hardwood, New South Wales, we weren't really comparing track speed of a wheelie versus a full track machine. Yes, a wheelie would be able to travel faster, but in the field, we didn't really assess the change difference. So I hope that answers your question, but yeah, we weren't really comparing the two, so I couldn't definitively tell you that a wheelie was tracking faster in the field than a full track. If we were to replicate the trial, where can we find the procedure to follow? Yeah, so all of this is available. So the Harvesting Best Practice Manual actually shows on our SRA website, shows how to conduct a mass balance trial. However, with the sugar loss trailer, the infield sucrose loss measurement system, that's a Sugar Research Australia. Sorry, that's conducted by Sugar Research Australia. So unfortunately, we're unable to. We would have to conduct that. Let's just say, because there's we've got all the algorithms in the background, and we have the machine to do so. So mass balance, anyone would be able to conduct. So yield change, you'd be able to conduct yourself just by measuring meters travelled by tons of cane in the bin by row spacing, and then assessing EM in the bin. However, in regards to the sugar loss trailer, that would obviously that's yeah, how Sugar Research Australia conducts it. But happy to talk to you offline further about that. Any other questions?
There is another one there about Hernan has said, is it fair to say that track harvesters perform better than wheel ones?
I wouldn't really be done. The reason, like, say for example, I'm in the Herbert region. You can't run a wheelie here because of the wet conditions that we have. That's the same further up north as well. I wouldn't be saying that a full track or a wheelie operates better than a full track. It's just with your circumstance on what you can cut and what you can't cut. And when you're in the north, and we do, we're a rain-fed region compared to, say, the Burdekin, where they've got wheel machines, completely different. I wouldn't really be comfortable in saying that one's better than the other. No.
All right, the questions have slowed for a moment. So what we might do is, I was just going to ask you one question actually, Phil. Just
Yep.
will there be a final report on that project? Because then that's
there is a final.
Oh, okay.
Yes.
So do you know if it's already uploaded to the SRA website? Okay, so that's probably something for people to perhaps be aware of. Sorry, e-library.
Yeah, so in the library there is. However, what I would direct you to go and see, because there is probably also, so the final report's good, there's a lot of information, but if you want something a bit more compressed and a bit more information, we've published a number of ASSCT journal articles about this. So you can look at, for example, the journal articles published by Sugar Research Australia and DAF has highlighted, so there's one paper that's showing what's out there in industry, as in gaining tonnes cane per hectare, but there's also a number of journal articles published by Brendan and his Brendan and Matthew Thompson that also highlights the cost change and what the cost actually means to the contractor and what he's gaining. So if you go to the ASSCT website, that's on there as well. If you go to our e-library, the final reports and the ASSCT papers on there as well. So yeah, they're all published, they're all available. If you need any help, feel free to flick me an email and more than happy to help you.
I'll actually put the link to the e-library in the chat as well shortly. And the SRA e-library has an administrator who's also available to help if you're unable to find anything on there. You can get in contact. I'll put her details as well. So we might, so we're almost on schedule. So Brendan, we'll hand over to you if you're able to share your presentation and yeah, we'll keep going. Thank you.
Thanks, Alison. I'm just waiting. Can you see mine?
Yes, definitely. It's appearing in presentation mode. Thank you.
Good, excellent. A very good morning to everyone online, and a big thank you to SRA for the opportunity to present some of the work that we've been doing from the department side and obviously in conjunction with yourselves. Before I even start the presentation, I just want to make a comment around what I'm going to be presenting. I know it's titled Development of a Harvesting Predictive Tool, but I'm also going to be just discussing some of the background to the direction that we're taking with regards to the tool. So that entails not only the journey that we've been on, but also some of the feedback that we got through a survey done in 2019. So I'll be delving into that a little bit. So just bear with me, and then we'll get into discussing the tool itself. So I'll start there. But if we go back to 2017, the reason why the department was asked to get involved in the project was specifically around the economics and dealing with some of the uncertainties around the cost changes when going to harvesting best practice. Quite interestingly, there were a couple of numbers being thrown around in industry at the time, but there wasn't a lot of work that had been done around the overall cost of harvesting. There were a few authors that had published papers around the cost of labor cost changes, but there wasn't a lot to go on. So we came in a little bit blind around what it actually costs to harvest at harvesting best practice. There was quite a lot of understanding around the revenue benefits, so that was well understood. We knew there was a lot of benefit for the growers themselves, but there was still a lot of uncertainty around what it was going to cost contractors and what impact it would have on contractors' businesses. So again, what did it pay, what did it cost, and who did it pay, and who did it cost? And that was really what we had to deal with from our side, which is great. It was really interesting, and to date we've been really lucky to be involved. So and it's shown really interesting results. I'm not going to go into the results that Phil's already spoken about, but just to say that yes, we saw a significant increase in revenue of just under 5% on average for all the trials. But more importantly, we wanted to get, as I said, get a handle on what was happening with the costs of the actual harvesting process itself. And if you look at that block there on the right-hand side in green, I'm sorry if you can't read it, it's quite small, but don't worry about the numbers. What I wanted to just highlight was that when we started doing the costs up front, myself and Matthew Thompson put together a model to be able to assess the changes in costs for the different practices. And what we started seeing was quite a high variability in the cost change, depending on the circumstances, depending on the conditions. And if you look at those initial ones we did, this was back in 2018, we saw significant differences. So taking the first one there, we did one in Central where we saw a relatively large increase in yield. It was actually an 18% increase in yield going from the standard practice to recommendation. And when we assessed the costing implications for the contractor, there was in effect a 67 cents per tonne saving for him. So that was a really good outcome with regards to that trial. But if we go to the other extreme and look at a trial where there was a relatively small increase in yield, for example, one of the trials that were conducted up in the North region saw only a 0.2% increase in yield. And in fact, what happened was that it actually cost the contractor close to $1 a tonne to change practice under those conditions. And the reason being that under all of these different examples, yes, we see an increase in yield. I mean, so you see an increase in cost per hectare. But when you start taking into account the differences in yields between the different practices, they have quite a big impact on the contracting costs when you take it down to a cost per ton basis. So as you can see, high variability. Initially, there was a question asked, what is that sort of magic number? If I were to adopt harvesting best practice, what should I be paying my contractor? What is it going to cost me as a contractor? And of course, what we soon found was that there is no magic number, that it really depended on the situation and the group itself. Some of the trial work that Phil didn't touch on this morning, this was a commercial demonstration that was conducted by SRA up in the Herbert. This was at the request of not only Wilmar, but Herbert Prod Services, the growers, the contractors up there in that region. And what they wanted to check on was that, yes, we believe the data from the research, but we want to see if it's actually practically possible to do it on a commercial scale. So what they did was that they identified 2 contractors that would run not only their standard practice, but also the recommendations from SRA over a full round. It included 12 trials, a number of different growers, but really what they wanted to see was was this actually possible out there, in a commercial scale, and what results would it give. To touch briefly on the results, and I'm not going to go into too much detail here either, but yes, we saw very similar increases in yield. The standard practice treatment went from 87 tonnes per hectare up to 92 tonnes per hectare in the recommendation. We saw no changes in CCS at all, which was really surprising, which was great, because we saw that in the trials, yes, but in this particular demonstration trial, there wasn't even a 0.1% difference, so they were exactly the same. We saw a slight increase in EM, but that wasn't a statistically significant difference of 0.2%. And so really, a really good result, very similar to the trial results. And again, it was just sort of underpinning, the value of those trials and what they were saying to industry. And yes, it was possible on a commercial scale. This is some of the economic results coming out of the 2 sets of trials. So yes, on the left-hand side in the blue, you can see the revenue change for the trials over 2017 and 18, those 95 trials. We saw $181 per hectare increase for the grower at a cost of $66 per hectare for the contractor and the levies. $61 of that $66 was contracting costs, so that was a $61 increase per hectare for the contractor. And what was left for the grower was $116 per hectare. Interesting to note that although we did see a slightly lower increase in revenue in the Herbert demonstrations on the commercial scale, we also saw a slightly reduced increase in cost as well, which left a very similar net benefit for the grower at $114 per hectare. So just to leave the results behind as I go into talking about the survey itself, we obviously understand that there's a level of variability between paddocks, between groups. But when we look at the overall results, there is a level of predictability in the economics, so that those net benefits were very similar, despite there being variability within the trial data, and between paddocks, and that was quite a good indicator that yes, if you were to adopt harvesting best practice, even without the tools that are coming up and are available at the moment, you would probably get 95% of the time an increase in your profitability. So that was a really good result from the trial perspective. Just a quick comment around the costing process. It's a really onerous process. For those who have been through the process, you'll probably understand what I'm talking about. But we looked at a lot of different variables. We made sure that we covered all the bases within the contracting group. And really, we wanted as an accurate an outcome as possible with regards to costings. So we have complete confidence that the costings that we did with the groups are pretty close to what was happening out there. But again, this wasn't really practically possible to do with every group. It's onerous, it takes time, and it needed specific modeling as well. So again, it's a very difficult question to answer if you are a contracting group. So if you're asking yourself, well, what is it going to cost me to go to a specific practice change or specific new practice? It's a very difficult question to answer without the specific tools that are needed to be able to answer that question. So again, a very involved process, and we're hoping that the tool that I'm going to be talking about in a few slides time, will be able to deal with some of these intricacies and obviously challenges in getting those numbers out. There's significant value in going to harvesting best practice. From the trial results that we saw, we determined a conservative estimate of $26 million available to growers. That's after paying for the harvesting costs. And just a comment here, that's not paying an incentive to contractors for making a change, but it's rather just making sure that they're not out of pocket. But again, $26 million a year on average. And I say it's conservative because for two reasons. Number one, some of the participants in the 2017 trials were contracting groups that were pretty close to the recommendations, so we didn't see big changes there. And another reason was that there's a high variability between paddocks, and if we had the technologies, which we're hopefully going to have in the next 2 to 3 years, if we had the technologies at our disposal, we'd be able to make a call as to which paddock we should be changing practice and which paddock we shouldn't. So, for example, under wet or dry conditions, there'd be a different response within the harvester and a different result. So, again, what is the most economically optimum results and settings for the contracting groups under those different conditions? A really important question to be able to answer in the future. But how? There's been a significant shift in the approach within the SRA projects, and it's gone from obviously doing a lot of trials and getting a lot of data to a more adoption focus. We're not doing as many trials now. Obviously, we've got more of a focus on the tool itself. And we've also found that economic data has become a key adoption driver. And on the flip side, the lack of economic data has also been a really big barrier to groups being able to change. So with all of those uncertainties, of course, a contracting group would be less likely to make a change if they didn't actually understand the implications for them and their business. And I mentioned again the survey that we conducted in 2019, and I'm going to go into a few of the results from the survey because that's underpinned a lot of the information that we're going to be producing within the tool, and also it's been a very nice survey to direct us in the development of the tool. So the survey was conducted in 2019. It involved just under 150 responses. 59% of the respondents were growers that didn't do harvesting at all. They had contractors doing harvesting or harvesting groups doing harvesting for them on their behalf. 28% were groups that did their own harvesting, and just under 10% were actual harvesting contractors, growers that contracted out to other growers. One of the questions we asked was, are you actually even interested in adopting harvesting best practice? There was quite a good result there. 65% said, yes, we're really interested. 23% had said they had already adopted harvesting best practice, and 12% said no. I just wanted to make comment to that 23% that had said that it had already adopted harvesting best practice. In fact, since I've been in the project since 2017, and when we got involved, the actual definition, and Phil's mentioned this already, the definition from my perspective has changed even in that time. It's gone from ground speeds to flow rates to now the economic optimization settings, the most economically optimized settings for harvesting. So even the definition has changed since 2019. So I think there's a lot of money still to be made out there. And for those of you who have already made changes, that's awesome, that's great. But we're hoping to get even more than that. So we're hoping that with the tool going forward, we'll be able to capture the very good wins there, depending obviously on your conditions and circumstances. What about barriers to adoption? This was the question we asked. What are your main barriers, or what barriers do you believe are the biggest barriers to adopting harvesting best practice? Only 50 respondents of the 148 actually listed a barrier, and 80% of those that listed a barrier focused on 4 key areas. Now I've just put a circle around those 4 key areas. Number 1 was the opposition by contractors. Of course, still a lot of uncertainty around there of the impacts on their business. Number 2 was the uncertainty of benefits and a lack of trust in the research. Number 3 was the cost uncertainties. And number 4 were the time constraints. And the more we got involved in the project, the more we understood that different areas had different constraints. Some areas have got two contractors at the moment, so there's a lot of pressure on them to cover the areas. So yes, we understand there's a lot of constraints out there, different constraints for different groups. But at the end of the day, what we wanted to do is provide a tool for industry to be able to make a call, dependent on obviously your own situation. Some of the tools, and again, this is going back to 2019, and there's been a lot of progress since 2019 to today. There's been a couple of road shows with some of the yield loss monitoring going on, and cane loss monitors and yield monitors that are out there. But at the end of the day, at the time of the survey, there was very little technology being used in this space. Only 18 respondents actually said that they were using one of these tools. Only 7 stated that the tool would help them determine harvesting charge rates. So overall, very low use of technology, and a lot of comments around, yes, we do it by feel, we do it through experience, and that's how it was being done. So again, in conversations with contractors, one of the contractors said to me, it takes you 20 to 30 years to actually learn how to drive a harvester correctly. So again, what can we do as industry to provide tools that can hopefully reduce that time, so we're not waiting 20 to 30 years for harvesting contractors to get to that point where they're driving that harvester well. We're not saying that harvesting contractors are doing a bad job. Everyone's doing the best job they can out there, but we're hoping that these technologies will help in that process. Another question, do you think a tool will be useful to assist you in determining a charge rate in your negotiations between the growers and harvesting contractors? 63% of the respondents said yes, and 26% said no. 11% said they own their own harvester, so it didn't really matter to them. Looking at other information that would assist you in adopting harvesting best practice, what the respondents said was, yes, there's a lot of information we want. This is just a few of them. They wanted information on yields, changes in costs, changes in revenue, changes in fuel usage, changes in speeds, charge rates, etc., etc., etc. So again, a lot of information was being put to us as to what would be necessary out there in order to help the whole process of adoption of harvesting best practice. Some of the others were billet length, cane loss, and reports being accessible to the grower. And there was one respondent that said maybe a change in attitude. So I liked his honesty there, and that was interesting. And again, attitudes have changed quite a lot since I've been involved. There was a lot of pushback around the project itself. But I think once everyone understood once everyone understands where they fit into the whole picture, where growers understand that yes, there needs to be some amount of that revenue benefit put into the contractors' pockets, the groups are able to move forward. So that's great. So we've seen a lot of changes in that space as well. Some of the other bits of information that were asked for, and this was really an open-ended question, so respondents could put down whatever they wanted, and we've tried to deal with most of them. Things like variety-specific losses, getting reports on paddock settings, obviously real-time data, so something that's been able to be used out there in the paddock while harvesting. Some of them fell outside of our mandate, things like base cutter blade settings, also chopper blade settings, base cutter height settings, etc., etc. If you look at the last one there, lotto numbers was one of the responses, which I found quite amusing. Unfortunately, we haven't got there yet, but we'll continue working at it. And just the last slide that I wanted to show you with regards to the survey, we had 94 responses to a question that was really posed to them saying, listen guys, do you want something that's easy to use but may not be as accurate, or do you want something that's a little bit more accurate that is a little bit more onerous? And 60% said something that's easier to use, and 40% responded, no, we would prefer something that's a little bit more accurate. We've tried to find a balance in that, and hopefully you can see that balance when I present some of the outcomes of where we are today around the tool process. On the right-hand side, we had 90% of the contractors that responded saying that, yes, the tool should estimate harvesting costs. So just for me, it just highlighted the need out there for help in this area, and we're hoping that the tool will help in that area going forward. So that's the survey. Getting into the tool itself, the predictive tool, plans in progress. Just a brief outline. Obviously, we've run a lot of trials. There's a lot of data. There's a lot of costing information now that we have at our disposal through what's been done over the last few years. A lot of this information we've been putting into algorithms and automating it. Really, the thinking behind the automation is that you don't have to put in all that information. That slide that I put up earlier around all the information going into the harvesting cost process. Of course, it's not practical to do that, out there in a tool. So what we've tried to do is automate a lot of those costs that were very similar between groups, so that just to make it easier to use the tool. And what we've done is we've started developing our Excel version, which, as Phil said, will be tested this season. We've already run some tests on the economic component of the Excel version with a number of different harvesting groups. And we keep on getting feedback with regards to the tool. So every time we get another comment, can it do this or should it be doing that? We take those on board. So it's changing all the time. Obviously, we're trying to make it better and better before we get to a point where we take it online. And of course, the last step will be to take it online so that it's made available to industry. We're hopefully going to be engaging a developer at the end of this year or the beginning of next year. So that's the plan. And there'll possibly be some hurdles to get over. But as Phil said, hopefully next year we'll have something that we can start testing with industry. So that's pretty exciting. Just a few comments around the Excel version. The Excel version is largely based around the time cycles algorithms. What I mean by that is that when we take the data from the groups, things like your group size, working times, harvest and haul out information, speeds, distances, etc., we're trying to get as accurate an output on things like cutting times, turning times, waiting times, servicing times, moving times. And once we've got that information, it's really nice to then link that into the agronomics. Obviously, we're currently developing agronomic algorithms to predict things like CCS and yield, extraneous matter, bulk density when relating back to bin weights, billet length, diameter, etc., etc. And of course, these two would work in combination. And once we have the answers from those, we then layer on the economics, and we get answers around what the dollars per ton and per hectare are going between the different practices. So that's where we are, and hopefully that's something that we can start testing this season. Just some of the conceptualizations around the tool itself. I'm going to talk specifically about 3 steps. The first step really, and just think about it, if you're thinking about it, once we've developed it, this is how we envisage you using the tool. So step number 1 would be obviously to get your group specific data onto your profile. So you'll download the program, you would then go into your laptop or your desktop computer, you would load up all your information onto your profile, things like your roster information, your haul out, labor information, what you're paying your staff, repairs and maintenance information would also go into that. There's a lot of automation around that as well. So it's not so onerous for you, and you would add your fixed cost line items just so you can get to a profitability figure. So once you've entered all that on, it will then be good to go. And the estimated time that we envisaged it taking you to do that would be between 45 minutes to an hour. So that would be a once-off process pre-season. You'd do it once a year. Obviously, you could update that information during the season if you wanted, but once you've done it, you can put it to rest, and then you've got all the information on your profile that would be the background information to the app itself. Just another comment is that once you've got that information in, it'll obviously be a lot easier to then update it from year to year. We believe the process will take you probably less than 30 minutes once you've got your initial information in. So hopefully that's not too onerous for you as the harvesting groups. Step number 2 would be actually using the app. So you'd be out there in the field. You would have the information, you'd have the crop sitting in front of you. You'd be determining whether it's wet, whether it's 100 tons or 90 tons sitting in front of you. So there's a bit of information that you'd put in there. The important thing is that all that information that you've added onto your profile would be sitting in the background, and that would pull through to the app and into the calculations on the day. You would then enter in all that information for that block, the yield, CCS, variety, etc. There are things that we're thinking around in making it easier for you to use that app. So, for example, from a variety perspective, we don't want to drop down with 100 different varieties, and you have to spend 10 minutes trying to find your particular varieties that you're cutting. We want to set that all up pre-season, so you'd determine which varieties you're going to be harvesting for the season, and then it would be in the drop down on the app on their own. So there might be 5 or 10 varieties that you could choose from. This whole process we think will take probably less than 5 minutes. I've just said 5 to 7 minutes, but you'll hopefully be able to do that in less than 5 minutes, and then you could obviously go and continue harvesting. This whole process in step number 2 is a very similar process in step number 3. Step number 3 is really a process that also happens pre-season. And this really relates to the ability to negotiate a particular change in rate. For example, if you have a grower approach you and say, listen, I want you to harvest at harvesting best practice, and I want you to determine what it's going to cost you over and above what you're charging us at the moment. You'll be able to do that by basically going through the same process as step 2. But what you're going to be doing is, instead of looking at an individual block, you would look at what we're calling a representative block. So you, for example, would say, well, 20% of his contract is at 100 tons a hectare. You would then put the information in for that, and you would allocate that to 20% of the contract. And really what that does is that you are able to decide what sort of blocks you're going to be harvesting for the season. Obviously, it's not that easy to guess that sort of thing, but it will give you a really good idea as to what sort of changes you'll be making in your business and what those changes will cost you. This process will take a little bit longer than step 2 because you're going to be deciding on what sort of representation it is of the full contract. But it obviously depends on how many representative blocks you decide. And you might say, well, 5 blocks is enough to represent that particular contract. Or you might say, I want to put in 20 blocks. And that's okay. That'll be up to you as the harvesting contractor and what you're comfortable with. Obviously, the more blocks you add in, the more accurate the actual result will be. And what the model will then do is we'll take an average of that, apportion it, and say, okay, well, if you look at the contract as a whole, this is what the cost increase will be. It'll be 30 cents a ton more the season. So that's what you then add on to the actual rate you charge the grower. To finish off, some of the objectives of the project going forward, to provide you with an in-field guide on harvester settings, not to target harvesting best practice necessarily, but to actually optimize grower profitability. So that's one of the main objectives that we're hoping will be fulfilled with this tool. To obviously help you negotiating new contract rates, in determining or in the process of changing harvester settings, looking at block to block or scenario comparisons. So this may just be for your interest. You know, what if you increased row spacing or reduced row spacing? What about row lengths? Looking at possibly improving efficiencies within your business. So there might be a paddock you're going to harvest, and you don't know if you want to bring in that 3rd spare haul out. Well, what's going to happen to your cost if you do, and is it going to be worth your while? So again, you know, is it going to be costly to have the harvester waiting for haul out, or should we bring in that spare haul out? Doesn't make economic sense. So hopefully the tool will help answer some of those questions. And again, just the last point, to complement other harvesting tools. Some of the cane loss and yield monitors out there are really great. Guys are already using them and seeing really good results. We're hoping to fine-tune those results. One of the questions I've asked at the forums has been, you know, what is the most economically optimum harvesting loss? And of course, the answer is there is none, unless you can actually identify those particular scenarios. You know, is it wet, is it dry, what variety, etc., etc., etc. Then you can possibly get to that answer. But we're hoping this tool will provide some of that information for you in the future. So that's all of it. That's all from me. I hope you're excited about it as we are. But if there are any questions, please feel free. And that's all from our side. So again, thank you for your time, and look forward to seeing you out there in the fields. So that's all for me. Thanks, Alison.
Thanks, Brendan. Wow. So we're just up against sort of 9:30, but hopefully people can stay on the line a bit longer if they would like to ask a question. So there are quite a few questions in the chat, but Phil, I know that you've been sort of answering some of them. So yeah. I'm just kind of looking back to see. There's a question there from Jonathan.
I might read them out for you, Brendan, and if you want to answer them. Sanaz has asked a couple of questions, good ones. Yep. I've tried to answer them as best as I can, but you're the economist, so I'll read them out to you and then you answer them. So Sanaz's response here, in terms of net benefit to the millers, have additional transportation and maintenance cost of processing additional cane been considered? If yes, can we please provide an estimate, e.g. dollars per tonne of additional cane?
Yeah, so we didn't get involved in the milling side of things. One of the things we looked at was bin weights, and that's as far as we got, unfortunately. Obviously, from a milling perspective, the thing that they probably interested in is EM, impact on EM, and what we saw coming through the trial data was that there wasn't a statistically significant difference in EM, so that was good news. So really, it's about, you know, increased yields which an increased tonnage going through the mill, so improving mill throughput, which hopefully is something that millers out there would be happy with. So again, the cost to processing, if there are changes in the actual product itself, we didn't look at that. And as I said already, there wasn't too big a difference in EM at the end of the day. So hopefully that answers the question. Yep.
Proper usage of fan or appropriate blade sharpening, which one plays a bigger part in HBP success? Okay, I'll answer that one. Look, they work hand in hand. The issue is that, look, if you've got blades with a massive hook in it, it's going to be disastrous. So literally, it's like I said, they work hand in hand. You've got to make sure that, you know, whether you're talking about chopper knives, whether you're talking about base cutter blades, whether you're talking about fan blades, you know, making sure that you're using the best quality material that you can, and making sure if you're talking about chopper knives, if you're talking about base cutter blades, they're or chopper knives as sharp as practically possible, base cutter blades as square and sharp as practically possible, and fan blades that they don't have massive hooks in them and they haven't been, you know, significantly worn and had, you know, 30,000+ ton through them. So they literally work hand in hand. You really need to make sure that A, you're not running really high fan speed, but B, you're not running a product that's not going to help you. Jonathan Pavetto, should we be changing the way we pay contractors instead of per ton? Should we pay per hectare or per hour?
Well, maybe should I answer that one?
Yep.
There are areas that are paying on a per hectare basis, and some of them combine the two, so per ton and per hectare. The tool itself is going to be giving answers around the per ton and per hectare basis. So it's really going to be, there's going to be an ability to do that with the tool. Whether you want to do it or not will obviously be up to the groups. Some prefer doing that. There's pros and cons in both. You know, per ton, you know, it's all about the incentives. It's about, you know, if contractors are paid per ton, then they want to obviously get the biggest throughput through in the quickest space of time. If they're paid per hectare, well, then they'll probably be more comfortable in slowing, you know, flow rates down. But I think there's probably a balance there, and that's probably why some of the groups have gone that route. Again, not easy to do, and maybe you can talk to some of those groups that have done it and how they found it. So that might be a good start, and go from there.
I'd like to also add to that really quickly. Sorry, Jonathan. Also, so for example, in Rocky Point, there are some areas that do a sort of a mix of the two. So Rocky Point, for example, some of the contractors there look at paying their driver and their haul out drivers per ton, and then their charge rate is a combination between per ton and per hour. So there are regions that are looking at mixing the two, because I understand what you're saying, that a lot of people get this mentality of, you know, let's just stick everything in the bin, and that's not beneficial either.
Yeah.
All right. Well, it seems like good timing. I think that's all the questions that have been put into the chat. I think we've addressed them all. As we said earlier, we did go a bit over, so that we will correct. But I know that both Phil and Brendan are happy to take more questions. Or is there something else?
Yeah, there's one more there.
Oh,
sorry.
okay.
We'll answer this one. Sorry. I'll just look. Can the tool in the future be linked to weather events, e.g. rain events and best harvest practice? Not weather. Maybe I'm misunderstanding that, but the tool won't be linked to weather. If you're talking about as in regards to field conditions, yeah, definitely. Like, so if we're talking about, you know, the tool now does it. So if you're talking about harvesting in wet, dewy morning versus hot, crisp trash versus really wet, yes, the tool does that and gives a recommendation in regards to what avenue to look at with different field conditions and crop presentation and crop conditions. If I'm understanding that question correctly, but it won't be linked to weather, no. So yeah, hopefully we've answered that question as well. So thank you.
Yeah. But I think over and above that question, probably the biggest challenge in using the tool at the moment would be deciding on what the estimated yield is in the paddock. And I think that's probably the biggest challenge. There are things that we're looking at with particular milling groups, saying, well, bringing in production histories and looking at that side of things. And there is other work in industry looking at improving estimation with other technologies. So I think in future it's going to become a lot easier. But this is where we're starting. So we're starting at a point where we're relying, you'll be relying on the harvesting contractor to decide on what sort of yield is there. And it'll probably be an important process to go through with the grower before actually getting results, deciding on particular harvester settings. But that is a challenge at the moment. But hopefully something that will be resolved with technology going forward.
All right. So thank you to everybody for joining us today. And obviously, thank you very much to Phil and Brendan for a great presentation, 2 great presentations. And there's obviously been a lot of interest. So I know that people will be able to reach out to you if they would like to follow up with anything. And I've put the links into the e-library. So if you have any, if you'd like to access that report, you can do that. And also Amber's contact details are there if you have any trouble accessing the SRA e-library. There's also the link to the survey, which again, I'll just put a bit of a plug in for that. It's probably disappeared up to the top of the chat. I might put it back down the bottom just to make it super easy for people to do that. Now, in terms of upcoming webinars, there's nothing, we don't have any dates of anything, but we've got some in the pipeline. At the moment for June and July, they'll obviously go on our website. We'll be emailing them out. If you're not on our distribution list, get in contact with me, or you can do that via our website and subscribe, so you'll get notifications of any further or future webinars. And I think that's about it. I don't think I've forgotten to give any reminders or any notifications. If you have any further feedback for me outside what might be in the seminar or in the survey, my contact details are also still on the website on any of our invitations. Yeah, I think that's it. So have a lovely day, evening, night, wherever you are. And hopefully we'll see you again next time. Goodbye.
Bye, everyone. Thanks very much.